Some hints for homework sheet 11. First question, you have to sketch y equals f of x add 2 take away 4. Well, the add 2 part in the bracket here means you've got to move your graph left 2 units, and the negative 4 at the end means you have to move the graph down 4 units. So take your graph, move it left, and then move it down. So if you take each of the points in turn, for example, negative 2, 4, if you were to move that left 2, you'd go to negative 4, and if you moved it down 4, you would go to 0. So if you do that for each point that's on the graph. Question 2, we've got a log graph which has the formula y equals log to the base a of x minus b. Well, the minus b part in the bracket tells you it's been moved to the right. Now this line here, the asymptote at x equals 4, is normally here on the y-axis. So that's been moved along 4 units, so that should tell you what the value of b is. Once you've got that formula, if you substitute in the point 8, 1 for y, log to the base a, 8 for x. Now remember, you've worked out what b is. Substituting all that in and doing a bit of calculation, it should be obvious what a comes out to be. Question 3, sketch this graph. Well, the coefficient at the front is 3, so that tells you what the graph's going to go up and down to. The positive pi upon 3 means the graph's going to be moved left pi upon 3 radians. Now remember, pi upon 3 radians is 60 degrees. So take your original cost graph, which looks something like this. That's your original. And you've got to move that to the left. So all of these points go to the left 60 degrees or pi upon 3 radians. Okay? Now once you've done that, then you need to note what this point is here where it crosses, what's this point here where it crosses, what's this point here where it's a minimum, and write all those down on the diagram. Question 4, very similar, the opposite way round. This time here is the graph, what's its formula? Question tells you it's of the form y equals a sine bx plus c. So let's deal with the b first of all. That's the number of waves that you would have in 360. Now here we've got one wave in pi upon 2. So how many more of those are you going to need to get up to 360? That's going to tell you what the b value is. How are you going to work out the a value? Well, the a value is half the distance between the maximum and minimum. So between 4 and negative 6 is how much? Half of that will tell you the a value. And then lastly, the c value, it looks like it's been moved down. Once you know your value for a, you should be able to find the value for c. Question 4, start with some functions work. F of g of x, you've got to put the g into the f formula. So this 4x is going to go into this formula here. So you're going to have 3 lots of 4x squared plus 2, which needs to be simplified. Question 6, inverse functions. So we start off by saying let y equal 4x squared minus 6. Rearrange that, 4x squared minus 6 equals y, and then change the subject until you have x equals. Once you've got x equals, you can then write down the inverse function as h to negative 1 of x. The inverse of h is, remember, turning y's back to x's. Question 7, we have to get from a to f. So we have to get from this point here, a, to this point here, f. Now there's many ways you can do that. Probably the quickest way to go is along the top and then down there. Right, so to get from A to F, we're going to go from A to B and then from B to F. Do you know what A to B is? Do you know what B to F is? Well, the answer to that is yes, because the question tells us that H to G is a certain value. You get that from the question. Now this vector is the same as that vector. It also tells us how you get from H to D. So it also tells us this vector. Now the negative of this vector is the one that takes you down the way. So basically the answer to the question is going to be an H to G movement, and then you're going to add on the negative of the H to D, and the numbers are in the question. Question 8. Prove that the points are collinear. Well, you're going to work out what A to B is first of all. Then you're going to work out what B to C is. You're going to find that there's some multiple between these, and then that multiple is also going to give you the ratio. Okay, that should be hopefully a straightforward question. Question 9. Find the coordinates of V that splits them in the ratio. Well, if you go back to your section formula, then 5 times this point, add to 1 times that point, divided by 6. That should give you the answer for the coordinates. Okay, remember section formula, 5 times negative 2, add 1 times 4, divided by 1, add 5, 6. And you do that for each of the points separately, and that gives you your new point. And then lastly, number 10, calculate the angle LMU, so this angle here in the diagram. How are we going to do that? First thing we need is what is the vector M to L, and you can do that by doing little l minus little m. What is the vector M to N? N minus m. So you get these two answers. You need to work out the length of vector ML. You need to work out the length of vector MN. You know how to do that. And then cos theta is just going to be the first vector dotted with the second vector divided by the length of the first vector times the length of the second vector. Check back your jotters, you'll see how to do that. It's fairly straightforward. Okay, and that should help you with the homework and hopefully with the unit assessment.